Hello everyone, welcome to today's lesson on factoring x squared plus bx plus c. Alright, so this is where we are going to do a lot of division stuff. And we're going to start with a simpler one. Alright, so this is the form where we have a polynomial that starts with x squared and then a number x plus another number. Right, so it'll be in the form of something like this, right, where we have number here for the x, number here for the constant, but then x squared just by itself with a coefficient of 1. Right, because if we have another number here, say like 3 for example, it gets a bit more complicated. So we're just working with this lesson. We'll deal with our next lesson though. Okay, so last time we talked about factoring with common factors. But most of the times we actually do not have something that's super nice to factor. Right, so just as a reminder, right, how do we expand this polynomial? Right, we can use our good old area model, right? X squared times x times x is x squared, 3 times x is 3x, right? 4 times negative 4 or negative 4 times x is negative 4x, and then negative 12, right? And then we add that all up. Alright, to get this. Alright, x squared equals x squared minus x minus 12. Right, and we notice something here. Right, this is the pattern we noticed last time. Right, so in an area model, we know that those two terms multiplied diagonally will be the same as those two terms multiplied diagonally. Right, so that's one of the properties of area model. This always has to be the case in order for it to factor nicely. And we also notice that this middle term right here is just those two multiplied together plus, right, so those two terms multiplied together plus those two multiplied together. Right, so this is just right, so this is just this multiplied together, right, 3x, and then those two multiplied together, which is minus 4x. Right, so this is how expanding works. So now let's try to go backwards. Right, let's try to factor this right here. Right, we can set up our area model again. Right, we know that in those two squares, it has to be x squared and 20. Right, because right, from here, we know that we must start with an x squared, and then with our constant must be 20. Right, the only thing we don't know is that those two terms has to add up to 12x. Right, so this is what we don't know. But what we also know though, from our area model before, is that those two terms, right, they multiply to 20x squared. Let me do it in blue here actually, so it's consistent. Which means that whatever those two terms are, right, they also have to multiply to 20x squared. Right? Again, this is the example from what we see earlier. Right? The two terms here diagonally have to be equal to each other, or multiplied together has to be equal to the two terms multiplied diagonally here. Okay, so this is actually all the information that we need. Right? So those two terms here, right, when they multiply to each other, we must get 20x squared. And then those two terms added up have to add up to this middle term here. Right? Because we can see here, when we add those two things up, 3x and negative 4x, we got minus x in the middle, right? Because we're just combining like terms here. Okay, so this must add up to 12x. Okay, so now we have to check pretty much everything, right? We don't have to check all the numbers because our biggest hint is that two numbers have to multiply to 20x squared. Right, there's only a few of those. We got 1 times 20, and they got 2 times 10. We got 4 times 5, but that's it. That's all the pairs of numbers that can multiply to 20. Okay, so we just check all of them. Let's say we have x times, I guess right here, this is why we should actually use the dot here instead of multiply. Because if we have x here and then multiply, they look the same. Okay, so if we have x times 20x, yeah, so yes, that multiplied to 20x squared. But x plus 20x is 21x, right, which is not 12. Okay, how about 4 times 5? 4x times 5x is 20x squared, which is correct. But 4x plus 5x is 9x, which again is not 12. So of course our last option is 2x times 10x. Those two will multiply to 20x squared. But we also notice that when we add them up, they get to 12x. Okay, so then we can slot it into our area model. Okay, and then that's pretty much it, right? So lastly, we just have to find out what are the numbers here on the edges, right? We know for sure that those two have to be x, right? Because x times, the only way to get x squared is just x times x. Okay, so now the question is, what numbers go here and here? Right, so let's see. What number multiplied by x is 2x? Well, that's just positive 2. Right? And then here, what number multiplies to x equals to 10x? Well, that's just 10. Well, positive 10. And we can double check here that yes, that gets us 20. Right? 2 times 10. So which means that this here factors into x plus 2 and x plus 10. Okay, and that's it. Right? And we can check over up here where the constants here are multiplied to get to our constant here. And our constant here are added to get to our term here. Okay, so that's how we factor. And of course, we actually don't need the area model if you don't want to. All we need to know is we look at this last number here. Right? What are two factors that multiply to 12 but add up to 7? That's pretty much what we're asking. So we can check the factors of 12 here. Let's look at 1 and 12. -1, -12. I remember, negatives also count. 2 and 6. -2, -6. 3 and 4. -3, -4. And if you can see here, this pair will add to 7. At the middle term here. Right, so we'll factor it like this, right? X plus 3, x plus 4. Right, the 3, 4 goes here. Here, let me actually highlight it so it's easier to see, right? The 3 goes here, and then the 4 goes here. Okay. And yeah, that's pretty much it for the entire lesson. So here, let's do some practice here. Right, so again, you can use either the algebra or area model. Right, I'm just gonna stick to algebra, but feel free to use whatever you like. I should have left enough space for both methods. So factors, we got 1 and 6, -1, -6, 2 and 3, -2, -3. Right, of course, we got this pair that add up to -7. Right, you can always double check. -1 times -6 is +6. -1 plus -6 is -7. Okay, how about negative? Right, so we have 1 and -10, or -1 and 10, 2 and -5, -2 +5. Right, so just gotta be careful here always about adding with negatives. X minus 2 and x plus 5. Right, so this was kind of weird, right? This right here is not in the right order. Right, we always have to make sure that it's rearranged so that we have the x squared plus bx plus c form, right? It's always going to be an x squared and a number x and then the constant at the end. Right, so whenever you see something like this, make sure to rearrange it. But from there, business as usual, right? We just have 8. So 1 and 8, -1, -8, 2, 4, -2, -4. All right, we got this guy here. Just like that. And here's our last one. 1 and 4. -1, -4, 2 and 2, -2, -2. Right, but we notice here that none of them actually add up to -2. Right, got 5, -5, 4, and -4, right? When we add them up, none of it is -2. So this is it. Right, so we cannot factor anymore. This is as factored as it can be. Right, sometimes it does happen. Okay? But other times, right, we also got some extra steps we gotta be careful of. Right, so let's say this one here. So this one here, it's pretty much saying what factors, right, what factors will multiply to -21y squared? Right, so right here, right, I actually did lie at the beginning, right? This last term doesn't always have to be a constant. Like, this last term just cannot have x in it. Or the variable in question. Because technically, this could be any variable. This easily could have been like a squared plus like 4ab minus 21b squared. Right? So as long as our last term doesn't include the variable of our squared term, right? Then that's count as the plus c part. Okay, so what's the factors of -21? Y squared. We got y and 21y. Oh, actually, sorry. It's -21, so -y and 21y. Y and -21y. We got 3 and 7, so 3 and -7 and -3 and +7. Okay, now same thing. Which one will add up to 4xy? Alright, so it's this one right here because it's positive 4xy. Or positive 4. So we got x minus 3y, x plus 7y. Alright, so I guess this is less so extra steps, but more so just something you have to recognize. Okay, how about here? Alright, so right here, this is not in the form of x squared, right? We got a number in front of the x squared. But luckily, it doesn't need to be there. Because if we remember from our last lesson about the common factors, right? All of those are divisible by 5. So we can actually take out a 5 here. So when we factor out the 5, right, we can divide everything by 5 to get this. And then from there, it's a lot easier. 1 and 12. -1, -12. And actually, as we've probably seen in a few examples by now, right? Because this middle number is positive, we actually don't really care about the negative factors. Right? Because if we have -1 times -12 or negative any number, it will always add up to a negative number. So the moment we see that, oh, this number here is positive, we actually don't have to worry about the negative factors at all. And just a little shortcut that you can use. So we only have 3 to watch out for. Right, again, the negative factors are still factors of 12, right? But because they all add up to a negative number, and our middle number here is positive, we actually don't have to worry about it. Okay, so which one add up to 7? 3 and a 4. Okay, make sure to not forget about the 5 that we factored out earlier. Okay, how about here? We got negative number, or negative x squared in the front. Once again, we do not like that. X squared needs to be just by itself, so we can factor out a negative. Okay, so we got 1 and negative 6, negative 1 and 6, 2, negative 3, negative 3, 2. Okay, and then from here, right, those add up to negative 5. Again, don't forget the negative sign in front that we factored out. Okay, lastly, this is not x squared at the front, but we notice here everything, we can factor out an x squared out of everything. Right, we can also factor out a negative 3, because all those are divisible by 3. We also want a negative. So we are factoring out a bunch of things at once. Right, so we're factoring out a negative, a 3, and an x squared, leaving us with this behind. Once again, since we're working with a positive middle term here, we don't actually have to worry about the negative factors. So just a 1, 9, and a 3, 3. So as you can see here, 3 plus 3 is 6. So x plus 3, x plus 3. Here's another extra step, because we can just combine the x plus 3 into x plus 3 squared. Right? It's just x plus 3 multiplied by itself twice. So we can just put a square on it. Okay, but with that, that's done. Alright, that's pretty much it for today's lesson. Alright, so here's a bit of a summary. Alright, so always make sure to rearrange it from x squared to x to constant, or again, just another term without the x. Right? And then from there, those are just some of the patterns that we see, right? If the middle term is positive, like this one, then the factors must be positive. If the middle term is negative, but the last term is positive. What's a good example? Oh, I still have examples here. That's my bad. Right, but again, this is just like some patterns that we can see. Okay, but with that being said, all we have to remember though is that, right, whatever this last number is, we find the factors of this last number, and then we just want to find the 2 factors that add up to the middle term, and then we just write it out into our brackets. Okay, so that's pretty much it for today, and yeah, good luck practicing.